Today we are going to find out how iPhone 6 boot circuit works. The boot circuit can be regarded as logic board trigger circuit. To have the phone turned on, working conditions like power supply, clock signal, and reset signal are indispensable. What's more, CPU have to get key components into power on, self-test, process, and get the boost strap imported. Since there are many components involved in the process, reasons for one turn on of the phone can be various. Repair related to one turn on of the phone is also an important and difficult part of iPhone repair. First, let's take a look at the main components on boot circuit. U0201 CPU. It awakes components related to the boot process, then gets these components into power on self-test process and gets the boot strap imported and performs as function controller. It is responsible for overall control of the phone. U1202 PMU. It provides power supply for working of the boot circuit. U0604 NAND flash chip. It stores data needed for the boot process. For example, systems and drivers. U1401 Charge controller. It converts battery power supply into main power supply. It also transmits battery percentage info to CPU. J2523 Battery connector. It connects battery with the logic board. Now let's find out how iPhone 6 boot circuit really works. 1. One of the boot working conditions, PP-VCC main. Power supply from the battery is outputted to power MOSFET Q1403 and charge controller U1401. If voltage from the battery meets requirements of boot process 3.6 volts to 4.2 volts, U1401 will send low voltage to Q1403, so that breakover of Q1403 will be completed. PP-BAT VCC will then be outputted by way of Q1403 and converted into PP-VCC main afterwards. Meantime, voltage outputted from PP-BAT VCC to U1401 will also be converted into PP-VCC main. After inner process of U1401, the voltage is then outputted via pin A2 of U1401. The two rails of main power supply will then be integrated and outputted to PMU. Second, PMU gets to work and outputs power supply needed. With main power supply being received, PMU will get the 32.768K clock activated. PP1V8 always is then generated. Then the voltage will be outputted to pin 2 of J0801, PMU and CPU separately. With the power button being pressed, pin 2 of J0801 is shorted to ground. Meantime, PP1V8 always will be pulled down, which, after the pull down process, begins boot trigger signal. With the boot trigger signal fulfilled, PMU will generate 10 rails of power supply voltage with the help of its inner buck circuit. Among them, there are 9 rails of voltage for working of CPU. 1. PP CPU 0.75 volts, 0.95 volts, 1.0 volts. CPU power supply. The voltage supplied varies from circumstance to circumstance. 2. PP GPU 0.9 volts, 0.95 volts. Power supply of CPU image processor, which outputs after the phone has been turned on. 3. PP VAR SoC 0.9 volts, 0.95 volts. CPU key power supply. 4. PP1V8 SDRAM 1.8 volts SDRAM power supply. 5. PP1V8 system power supply. 6. PP1V2 SDRAM power supply. 7. PP1V2 CPU power supply. 8. PP0V95 fixed SoC CPU key power supply. 9. PP1V0 CPU power supply. 2 rails of voltage for working of NAND flash chip. 1. PP1V8 2. PP3V0 With the 2 rails of voltage fulfilled, NAND flash chip will then generate PP1V2 NAND VDDI. 3. CPU starts to work and extracts data needed for the boot process. For NAND flash chip and logic apron IC, with power supply needed fulfilled, CPU will get the 24 MHz system clock started. PMU will then output an 1.8 volts reset signal to CPU. With the reset signal being received, CPU will extract data needed for boot process from NAND flash chip and logic apron IC. Then CPU will get these key components into power-on self-test process, get the boot strap imported and driver sent, so that components and applications needed for the boot process will be awakened. Once done, CPU will send KEEPACT signal to PMU, so that PMU will get the phone power supplied continuously. And this is the whole boot process of iPhone 6. Now let's move to repairing of iPhone 6 won't turn on issue. First, replace accessories and display assembly. Confirm whether the issue is caused by accessories of software by restoring via iTunes. Then, check indispensable conditions for boot process of the phone. 1. Measure battery power supply, PP-BAT VCC. Measure main power supply, PP-VCC main. And then 10 rails of power supply from PMU. 2. Measure the boot trigger signal. 3. Clock. 32.768K standby clock. 24 MHz system main clock. 4. Measure reset signal and keypad signal. Once we have done checking with these conditions and nothing goes wrong, we can judge by the boot current. 1. If the boot current is normal, check display relevant circuit. If the boot current is abnormal, then we can judge by the specific current reading. 2. iPhone 6 won't turn on accompanied with large current when connecting the phone with power supply or pressing the power button. The fault is usually caused by short-circuited components. We can locate the fault component by rosin detecting or temperature detecting. 3. Press the power button to power on. The current reading is 0 to 20 mA, which indicates that PMU is not working. We need to check working condition of PMU, PP-BAT VCC and PP-VCC main, and relevant circuit of power button. If nothing goes wrong, run diode measurement of PMU relevant pins. If the problem remains unsolved, replace PMU with a new one. If the measured value of one specific pin is abnormal, then check relevant circuit of the pin. 4. Boot current is 20 mA or above, which indicates that PMU is working. We can start with indispensable working conditions of CPU. If nothing goes wrong, connect the phone with computer and check whether the phone is in DFU mode. If the phone cannot be recognized by computer, then replace the USB controller. If the phone can be recognized by computer, then confirm the fault position by iTunes error code. Common fault components of the boot circuit. Malfunction of USB controller U1700 will result in issues like won't turn on, not recognized by computer, and so on. Malfunction of U0604 will result in issues like won't turn on, stuck in Apple logo, and so on. Malfunction of U0201 will result in issues like won't turn on, stuck in Apple logo, reboot loop, and so on. Malfunction of U1202 will result in issues like won't turn on, stuck in Apple logo, and so on. Malfunction of Q1403 will result in won't turn on of the phone. Malfunction of J2523 will result in issues like won't turn on, stuck in Apple logo, and so on. Malfunction of J0801 will result in won't turn on and some other problems. Malfunction of C1505, C1530, and C1531 will result in won't turn on accompanied with large current issue. Malfunction of C0610 and C0633 will result in won't turn on of the phone. Malfunction of U1401 will result in won't turn on of the phone. And this is our detailed explanation of how iPhone 6 boot circuit works. Feel free to visit our official website www.rivatechnology.com. See you next course.